Okay, in this video, what we'll do is we'll go through and demonstrate how to run a vehicle simulation using the MATLAB API, sort of a basic set of runs. So what we can do first is we go to the project folder and we run the A startup file. That sets all the paths in MATLAB so that MATLAB can find the various files and functions that are used in the API. So what we'll do next is then create a new script. One thing that we can do if you want to run a really quick simulation, what you can do is you can just do a PXF run cycle, and you can set the vehicle to, say, let's run a conventional vehicle here. Run a conventional midsize SI, spark ignition, 5-speed, transmission, automatic, a vehicle. And then what we could do is we could set the cycle property on it. So there's this cycle, and we could set that to an FUDS 1, a cycle. You could do other things here too. If you want to run a couple of cycles, you can do that. So you could set the cycle number to, say, 2 or 3. And now what you do is you do cycle.run, and that will run the simulation for you. So this is true for any of the other procedures. So if you want to run an acceleration test, you want to run a 2-cycle procedure, a 5-cycle procedure, the same thing is done. You instantiate it, set the vehicle, set the cycle, and then run. So let me save this, and we'll just call this example. We'll just call this demo 1. Except run cycle. And so now I'll run this simulation by just hitting the run button. Oops. One thing you should do before setting any of the other properties, these 2 properties are safe to set, but one thing is you should initialize it first before any of the other properties are set, because it has to load the internal state. We could do this initialize using defaults. There's a couple of ways to do it. So this is the first way. So what this will do is it'll initialize the state and load all the subclasses, such as the class that handles the cycle inside run cycle, so that you can actually set properties. So if you have an issue where you can't set the properties, it's because this wasn't called first. There's another way to also initialize it. I'll do that next, but let's run this now. So what that will do is it will initialize the vehicle. So it'll evaluate all the initialization files and pre-processing files and scaling files that are referenced in the vehicle. And then it will build the diagram for the vehicle. It will create the save folder. It will run the simulation. Then it will save the diagram, a vehicle file, an initialization.mat file, and the final results.mat file, all to the same folder. You can see that the vehicle diagram is built, so it creates that vehicle diagram from all the submodels. So there's for every system, so if you have an engine system, you'll have a controller block, you'll have a plant block. So the engine controller will itself be composed of subblocks, such as a command, a constraint, a transient, and a demand block. So it'll assemble those blocks for the controller, then it'll load the plant, assemble that module, and then it'll go on and do it for the other components, for the gearbox and the final drive and the chassis. It'll build all those models and create the diagram that's then simulated. Now it's all running within the method of the PXF run cycle class. So when the simulation completes, you won't have any of the results in the workspace. If you want to analyze the results in the workspace, what you can do is you could go to the data.mat file that will be saved out, load that, load the diagram, and run it that way. So now the simulation is completed. What is produced from the simulation run is this result, and you can access the result on cycle by doing result. It's a cell array that contains this PXF result class, and to get the actual, say, path, which is a cell array, you can do it that way. So we can navigate to that folder also and look to see what was saved. So as I mentioned before, you have a data initialization, which has all the initialization parameters for it. You have an A vehicle file that's saved out that has all the options that were used to create the vehicle, all the init, all the pre-processing, all the scale, all the models, all the configs, everything that was used to create that vehicle, except for the actual cycle information. That is saved, but it's saved in this data.mat. You can load the diagram by opening up this SLX file. There's also an HTML report that's saved. So you can see the various results in the HTML report. It has the model that was run. It has the cycle that was run. It has the distance, fuel economy. So all that information is in the cycle file. If you want to, you can, now you'll see that there's nothing in the workspace here. We could clear the workspace. We can go back here. We can clear the now what we can do is we can load this data.mat or the data init.mat. Let's clear the workspace first. Load this data init.mat, and then we could open up the diagram and we could run the Simulink diagram. And that will rerun the simulation. You can see the diagram is running now. I could stop that. So that's one example on how to run it. So if we go back to the runs folder and we go back to the file that was there, another way that this can be done instead of doing the initialize using false is there's a constructor method. Probably good to initialize it with this create initialize using process with class. So that way you can load the actual A process file and use the A process file to initialize it. So the A process file has all the basic defaults in it. So we can look at the A process file here and kind of see what's in the A process file. So there's a lot of default information that is set. So these are all properties on the class that's defined here. So there's a .m file that corresponds to this class, and then there's an A process file. And then if you say, oh, give me the properties on this class, those are the same properties that match up here with the default values. So that's why it's sort of a good thing to initialize using the A process file, because then you'll get all the defaults that are being used when running a simulation. You can always customize it, create your own version of this A process file, and then load your custom version. So that will set the properties using whatever defaults that you would want. So that's another option. So what we can do here is, now that that's set, we could So we'll run it this way. What I'll do is I'll just change the cycle. So we'll use a highway cycle. And we'll run the highway cycle twice. So I'll run that simulation now. So if you're running one cycle, or you just want to run a few cycles in a loop, this is a convenient sort of way to do that. Again, it's going through the same process of assembling the model from the individual plant and controller Simulink diagrams, assembling it, running it. It initializes diagram, runs it. It figures out the order in which to evaluate the initialization, preprocessing, and scaling files. So those are all files that are defined in the A vehicle. It will go through and figure out what order to evaluate them in. So here's the second simulation run. So I could do the same thing here. We'll clear the workspace. And we could load the data.mat file in this case, which has the results. So we could quickly plot. Time simu is the time for the simulation. We could plot the chassis speed. You could see that we ran 2 highway cycles. You could plot the driver speed demand. So this is the speed that the driver demanded. Ideally, the two would match. There is going to be some difference because the driver is responding between the difference between the driven trace and the desired trace. So I could copy and paste these on top of each other, and you can see that the difference is minuscule. You'll have to, zoom in to really see any significant difference between the two. You can find engine speed. You have engine speed. You can find engine torque. So speed, SPD, torque, TRQ. You can find engine torque. If it was a hybrid, you can look at the motor torque. You could look at the motor speed. You could look at the battery state of charge. In this case, we're just running conventional, so those would not be as interesting. We could look at the gear simu. So we could look at the gear that's being chosen at each time. So on the highway, you can see we shift into 5th gear, which is the top speed for this vehicle. So that's a brief overview of quickly running a simulation using a little bit lighter weight API when you just want to run one vehicle simulation at a time.